Okay, before we begin, can I just get confirmation from you guys that you guys can hear me as well as see my screen? Okay, perfect. As well as the YouTube chat, please confirm with me that you can hear me and that you guys can see my screen. Okay, perfect. Sorry that we're slightly late. It's just we ended the previous class slightly late. Okay. So, assalamu alaikum and hello. Welcome back, everyone, to grade 12 mathematics by Inspired Yins. Please do remember, if you guys have any questions, leave them in the chat as well as in the or in the Q&A, whichever one, as well as in the YouTube chat. Perfect. You guys can hear me. You guys can leave your questions there as well. Okay, so today we're going to be continuing with sequences and series. We're going to start off where we left last week, and we ended on our arithmetic. And today we are going to start quadratic and hopefully get to complete the section, hopefully, right? So let me just, okay, perfect. Okay, so let's talk about quadratic. So quadratic sequences. So quadratic sequences have a constant second difference between consecutive terms. Okay, again, Tn is the general term and n is the number of terms. Okay, notice how similar this quadratic equation and the formula of parabola is. That's really important, guys, to note. Okay, for some more difficult questions, you need to note that this equation is the same as the parabola graph. Okay. Okay, so before we get there, let's discuss this. Firstly, our general term is Tn is equal to an squared plus bn plus c. An squared plus bn plus c. That is the general equation for quadratic. Now, how do we solve for these unknowns, a, b, and c? Okay, remember, in our general term, in Tn, we have to have one unknown, which is n. If we want to identify a formula that can calculate any term in that pattern, we need to have n there so that we can substitute anything for n. If you want to calculate the first term, the sixth term, the seventh term, the 25th term, we substitute it in for n. Okay, so in all our Tn's, we're going to have our unknown as n. Okay, so these are basically the steps that we need to use in order to calculate a, b, and c. Okay, so 2a is equal to the second difference. Okay, 3a plus b is equal to the first difference, and a plus b plus c is equal to the first term. Okay, so it might not make sense now, but let's do a practical example. So it says, study the following pattern, 1, 7, 19, 37, and 61. Okay, so let's do 1, 7, 19, 37, and 61. So firstly, let us try and identify our differences between each pattern. Okay, so I'm going to distinguish the first differences. So for example, between 1 and 7, okay, the difference is positive 6. Remember, the sign is very important because sometimes we subtract and it makes a difference. Okay, so to go from 1 to get to 7, I added 6. Then to go from 7 to 19, okay, I actually added 3 plus 9, 11, I believe. 12, sorry. Okay, I've added 12. To get from 19 to 37, I've added 18. And to get from 37 to 61, I've added 24. So opposite to arithmetic or different to arithmetic, in a quadratic pattern, we don't have a constant difference as a first difference. So remember, in arithmetic, right? Here's an example. We don't really have things that we did, but let's look at this arithmetic pattern. As you can see, between T1 and T2, the difference is plus 5 again, plus 5 again. Okay, it's a constant first difference. However, in quadratic, there's no constant first difference. There's actually a constant second difference. If we notice the differences between the first differences, this is plus 6 each time. So now we can see, okay, the first differences have a constant second difference of 6. Okay, so in that case, when we are talking about second difference, that's what we mean. Okay, so now they say, what is the next number in the sequence? Okay, so we can just use maths to do that. So firstly, we have to calculate what's going to be the next first difference. So we're going to add 6 to that first difference. When we add 6 to 24, we get 30. And now we can add that value, 30, to 61, and we get 91. So that's the next term in the sequence. Determine Tn. Okay, so remember for quadratic, Tn is equal to an squared plus bn plus c. Now, n we find with being an unknown. However, a, b, and c we need to solve for. So that's where this guy comes in. In order to solve for a, we need to say 2a is equal to the second difference. 2a is equal to, now our second difference in this case is 6. 6 is our second difference. Okay, it's a constant second difference. So I am going to say 2a is equal to 6 and solve for a. So I divide, in that case, I divide both sides by 2, or I take 2 over as division, and I get a is equal to 3. Okay, a is now solved for. Let's look at the next one. 3a plus b is equal to first difference. Okay, so 3a plus b is equal to the first difference. Now, there are multiple first differences, but we are basically talking about the first difference, which in this case is also 6. The first difference, technically. Okay, the first difference. Which is 6. So I'm going to say 3a plus b equal to 6. Now remember, we solved for a. A we solved as 3. So I can substitute that in there. So 3 times 3 plus b is equal to 6. Okay, so when I solve for b and I leave b alone, I take this is 9, I take it over, it becomes negative 3. If I have any calculation errors, please stop me to correct me. Then finally, let us solve for c. How do we solve for c? Using the last one, a plus b plus c is equal to the first term. My first term is 1. So I'm going to say a plus b plus c is equal to 1. A I solved as 3, b I solved as negative 3, c is equal to 1. Okay, so that's basically how we solve for a, b, and c. We've solved now for Tn, because Tn is equal to a, which we solve for 3n squared plus b is negative 3, so it actually becomes minus 3n. C is 1, so plus 1. So now we've solved for the general formula, right? That's 3 marks. Okay, please grab onto those marks. There's no need to lose those marks. 3n squared minus 3n plus 1. What? Okay, by the way, this is not given in the formula sheet. You need to memorize this. Okay, you need to memorize it. So this was 1.2. 1.3. What will the 30th term of the sequence be? So the main thing in these type of questions, you need to identify, is n given or is Tn given? Is n given or is Tn given? In this case, could you guys please tell me, is n given or is Tn given? Is the value of the term given or is the actual term number given? Term number n, Tn, I have a Tn. Term number, the value. Term number. Okay, term number n is given, right? For that, the person who said Tn and the value, that is incorrect. Okay, Tn is not given in this case. Why not? So one of the keywords is this thing here. I forget what it's called in English. 30th, third, fourth, 61st, whatever. Right? That's actually a hint to tell you that they are actually talking about Tn in that case. Okay, because remember, sorry, they're actually talking about n. Okay, the reason they're talking about n is because remember, n is the term number. So it's which term are we dealing with in the sequence? Are we dealing with the 5th, the 6th, the 27th, whichever one, right? And then the value of the term, for example, the 27th term in a certain pattern could be 562. Okay, in that case, Tn, okay, is actually the value of the term. Okay, what is that term equal to? What is the actual pattern value in that case? So for example, here, this is T1. So here, n is equal to 1. For this first term, n is 1. Then for 7, n is 2, n is 3, n is 4, n is 5, and so on. Alternatively, we could represent it as T1. Okay, so Tn, if this is T1, that means n is 1. T2, T3, T4. But when we talk about T5 and so on, when we talk about Tn as a whole, then we're referring to the actual value of that term. Okay, so in this case, for example, for this specific pattern thing, right, T5 and 61, N is 5. However, Tn is 61. So it's basically telling me that the fifth term is 61. The value of the term is 61 and N is 5. So the fifth, that is annoying to say, the fifth term is 61. So what will the 30th term of the sequence be? So I'm going to use my formula that I just worked out and substitute 30 as N, because they want to know what is the value of the 30th term. N is given correct in YouTube. Okay, so Tn is equal to 3 into 30 squared minus 3n plus 1. Let me just do this calculation quickly. Sorry. Minus 3 into 30 plus 1. Okay, sorry, if the values are incorrect, I don't have the memos next to me, so I'm just going to be using my calculator. But it's not important as long as we got the steps down, right? Okay, so now let's do 1.4. Which term in the sequence is 271? Okay, so now tell me, are they asking for n or are they asking for Tn? What are they asking for in 1.4? Are they asking for n or are they asking for Tn? Okay, I see a lot of Tn's. I think some people are confused. Tn is given. Okay, but they are asking to get n, correct? Okay, they are asking you to find out n. Which term? Okay, if you had to answer that, just any number, which term you would have to say the first term or the second term or the third term or the fourth term. And remember that little THST thing, that's a hint that that's for n always. Okay, so in this case, which term of the sequence is 271? So they're not asking what is the value of the 271st term. Nope, they're not asking that. They're asking which term in the sequence basically has a value of 271. So Tn is given, n is the question mark. In that case, we are going to now say, remember this is our formula. So wherever we have Tn, we are going to substitute 271 and equate it to the formula. So we are going to say 271 is equal to 3n. N is unknown, okay, because I need to know which term is in that pattern is 271. 3n squared minus 3n plus 1. And now I'm going to solve using the quadratic formula, actually, because I have a trinomial. I need to take this guy over. Okay, I'm flipping the equation, so the signs will stay the same. Take him over, it becomes 1 minus that becomes minus 270 is equal to 0. So now I need to solve using quadratic formula. So you can use quadratic formula, or alternatively, you could even just factorize. All right, let's just quickly use quadratic formula. I'm going to simplify this. Dividing by 3, that's minus n minus 90, I believe. Okay, is equal to 0. In minus plus 90, 1. It's like 10. So minus 9 plus 10, no, minus 10 plus 9. N is equal to 10, or n is equal to negative 9. Is that correct? Because I'm going to get minus 10 plus 9, which is minus 1. And then, okay, perfect, right? So n can never be negative. You can't have the negative 72nd term. Okay, n always has to be positive. However, Tn can be negative. Okay, n is always positive. Remember that. Tn can be negative, however. Okay, because n again is the term number. So we only have first term, second term, third term, fourth term, fifth term. However, those values could be equal to negative values. Okay, so we cannot choose the negative answer. We would therefore choose 10. So therefore, in this case, which term of the sequence is 271? It's the 10th term, which is equal to 271, or T10 is equal to 271. Okay, so the basic question with all the basic examples. let's move on. So quadratic, yeah, quadratic done. Okay, actually it's not done. There's one more thing we need to talk about. Okay, there's a question that we need to do. Okay, let's just discuss it now, then we can maybe do that question. Okay, so one thing I want to talk about, okay, I'm going to write this term. I'm going to write this 1, 7, 19, 1, 7, 19, 37, 61, 91, 37, 61, 91. So one more thing about quadratic that's really important for us to understand. Let's just do this. So remember we said plus 6, plus 12, plus 18, plus 24, and then plus 30. Then we have plus 6, plus 6, plus 6, and so on, right? Whatever. Okay. So now, yes, this is quadratic. Okay. Remember, this is our quadratic pattern. This is our first differences. This is our second set of differences. Remember that the second set of differences are always common. It's like common, right? Just like arithmetic keyword. What we need to note, okay, for what is this called quadratic, is that the first differences actually form an arithmetic or linear pattern. Arithmetic linear is the same thing. First differences form an arithmetic pattern. Arithmetic sequence. I think that's how it's spelled. So let's analyze this. First differences form an arithmetic sequence. Okay, so that makes sense because remember, if I just consider if this did not exist, if I just had to consider this 6, 12, 18, 24, 30, and then I identify the differences and I notice that their differences are constant, okay, in that case, okay, you can say, oh, okay, this has constant first differences, and therefore it is an arithmetic sequence. Okay, so it's that simple, right? You need to utilize that understanding. 1 second. Okay, you need to utilize that understanding to see that, oh, okay, the first differences actually form an arithmetic sequence. Okay, if I get rid of that and that exists, you need to identify that, okay, we have quadratic, we have first differences of quadratic, we have second differences. Okay, the first differences, what did I just do? The first differences is like a pattern on its own, 6, 12, 18, 24, 30, that create an arithmetic sequence. Okay, so that is really important to know. One more thing about it that's important to know is, let us identify, okay, so in my arithmetic, again, let's just ignore that for now, right? In my arithmetic, I have T1, I have T2, I have T3. Okay, in my arithmetic or my first differences, I have T4 and I have T5. I have T1, T2, T3, T4, and T5. All right. Now, let us look at my quadratic, okay, and write down which term I have of each one as well. I have T1, T2, T3, T4, T5, T6. Okay, so if you notice, you actually see that the first term, okay, so I'm not going to refer to it as a first difference anymore. I'm going to call this the arithmetic. The first term in my arithmetic is actually the first difference between 1 and 2. The second term in arithmetic is actually the first difference between T3 and T2. Now we're talking about the arithmetic being a difference between the quadratic. Okay, T4 in arithmetic is the difference between T5 and 4. So T4 and 5. T5 between 5 and 6. Okay, so if we had to have T72 in arithmetic or linear, let's just write linear because it's okay. Let's write arithmetic because we've been writing it this whole time. arithmetic. If I have T2 in the arithmetic and the question says, between which two terms in quadratic is the 72nd term in arithmetic, it would be T72 of quadratic and T73. So it's always itself and one above in the quadratic. So the 72nd term in the arithmetic is actually the first difference in the quadratic pattern of the 72nd and 73rd term in the quadratic. Okay, I have a question to solve questions with unknowns. Are you talking about for quadratic? Or just in general? Okay, so this is very important to note. Two things. Firstly, that the first differences of a quadratic pattern form an arithmetic sequence. And the second thing is that difference, the term in the difference always is difference between the number itself and one more than it. So the 72nd term in the arithmetic is actually the difference between the 72nd and 73rd of the quadratic. Okay, I don't know if I have an example right now, but I can see if I have one and I can try and find one. Okay, let us just look at the examples that we have. Okay, let's have a look at this example just to see how they ask it. How would you write the answer? Okay, so it depends on the question. Okay, like that's why we'll do this question to see how they answer it. The main thing right now is for you to have that understanding so that you know certainly, okay, I know that the first differences are in arithmetic, and I know this concept of which term, which difference is it between which two terms in the quadratic it is. So for example, if they had to ask in this case, between which two terms is the first, between which two terms in the quadratic is the 72nd term in arithmetic, you would say between T72 and T73 in the quadratic. Okay, so it just depends on the question, but you have to have that understanding. Okay, let's do this question quickly. Okay, so they say consider the quadratic sequence 72, 100, 120, 132, blah, blah, blah. Determine Tn, the nth term. Okay, so I'm going to speed through this because we did an example already, right? So, the difference here is 28. The difference here is 20. The difference here is 16. Yeah, we're adding or subtracting? We're adding. Is it 16? No, it's 12. Yeah, we're adding each time. Difference here is we are subtracting 8. Okay, so it's important to note the subtraction as well. -8, so I'm going to say 2a is equal to the second difference. So 2a is equal to -8. A is equal to -4. 3a plus b is equal to the first difference, which is 28. So b is going to be equal to 28 plus 12, which is 40. Please, if my values are incorrect, stop me. Then a plus b plus c, so -4 plus 40 plus c is equal to 72. So I need to say 72 plus 4 minus 40, which is 36. So I've solved for Tn. Tn is equal to -4n squared plus 40n plus 36. Okay. Now let's look at the main question that we want to do. So that's a simple question, 2.1.1, right? It's solve for Tn. Okay, you need to do some computation, segmentation. Okay, we're going to try and get there. Okay, a term in quadratic sequence 72, 100, 120, 132. Okay, so we're dealing with the same quadratic as in the previous question. They say a term in the quadratic sequence is equal to the 12th term of the sequence of first differences. Determine the position of this term in the quadratic. Term in the quadratic is equal to a 12th term in the sequence of first differences. Determine the position of this term in the quadratic. Okay, So in this case, okay, this question is a bit complicated. It's referring to a term in the quadratic and a term in the first differences. So in this question, the first thing is that you need to understand that the first differences actually form an arithmetic sequence. Arithmetic sequence. That's the first understanding you need to have in order to answer this question. Then you will say, okay, this term in the quadratic, okay, it's equal to, so the value of this term is equal to the 12th term in the sequence of first differences. So basically T12 in arithmetic. So I need to get the value of that term. Okay, how? By solving for the arithmetic. If I ignore the quadratic, I have an arithmetic. I can use the arithmetic general formula to solve for it. So remember, the arithmetic general formula is Tn is equal to a plus n minus 1 times the difference. In this case, a is, this is my arithmetic, 28. 28. Remember, I'm dealing with the 12th term in the series of first differences. So 12 minus 1 times the differences. The difference is actually negative 8. Okay, is equal to Tn. I get 28. I get 11 times negative 8. Negative 88 plus 28. I get negative 60. So negative 60 is the, actually, this is T12 of arithmetic. Okay, so that's the understanding you need to have for this question, is that you need to know that the first differences form an arithmetic. In this case, T12 is equal to negative 60. So I know that the 12th term in the arithmetic is 60. And then they say that this 12th term is equal to, what is it equal to? A term in the quadratic. They want to know which term in the quadratic is that. So now I actually have the value of that quadratic. I need to find n. So remember, the quadratic is Tn is equal to negative 4n squared plus 40n plus 36. In this case, I've solved for Tn because I know that this term is equal to the 12th term in arithmetic. 12th term in arithmetic I solved for. So I know that the term in quadratic that I'm solving for is equal to that term. So negative 4n squared plus 40n plus 36. Negative 4n squared plus 40n plus 96. Okay, and then you solve quadratic formula or factorize. Okay, and that basically now gives you the n, which is the position, whatever n is, which is the position of this term in the actual quadratic sequence. Okay, let's just do this last one while we're at it. Determine the maximum value of the quadratic sequence. Remember, we said that, what did we say? We said that the quadratic is very similar to the parabola. That is because it's true. Remember, in parabola, maximum is actually the turning point. Since we have the same structure of the formula, we can actually, turning point we can do for maximum value, we can do negative b over 2a. Negative b over 2a, what is b? 40. Um, 2a is negative 4. So negative 40 over negative 8, 5, I think. Okay, so now we've actually solved for the n. We solve for n. Okay, determine the maximum value of the quadratic sequence. We've solved for n, so we know that it's the 5th term that's maximum, but they actually want the value. How do we get the value of the 5th term? By subbing it into the equation. So negative 4, 5 squared plus 40 into 5 plus 36. We get 136 is the maximum value. This is actually T5, I believe. So T5 of this is the maximum value of this quadratic. Okay, let's move on. Okay, going to move on to the geometric sequence. Okay, A sequence formed by multiplying the previous term by a common ratio. So this, I believe, is grade 12 now. A sequence formed by multiplying the previous term by a common ratio. Okay, so in this case, when it comes to geometric, we are not adding or subtracting that common difference. Now we are multiplying what we call a common ratio. So we multiply each term by the same number. So a sequence formed by, okay, we read that. Okay, let's look at the formula. The formula for geometric is Tn is equal to A times R to the n minus 1. So A is the same. A is the first term, right? T1. Then Tn is the same, it's the general term, and n is the same, it's the number of the term or the term number. But now this is new, the common ratio, R is the common ratio. So again, it's basically you are multiplying instead of adding or subtracting. So for example, I have 1. Just say my common ratio is 3. So I can multiply by 3 each time. 3 times 3, 9, 9 times 3, 27, and so on. So I am multiplying by 3 each time. You could also multiply by a fraction as well. Okay. Okay, I will do that. Okay, right. So, so we're multiplying by the common ratio each time. Okay, I hope that makes sense, right? It's a basic concept. It's similar to arithmetic, okay, or quadratic in that sense, where it's just instead of adding a common difference each time, or even just adding a difference, this time we are multiplying a common difference. That is the most important thing. Our general formula, these general formulas are given in your formula sheet, okay, are given. Okay, A is first term, R is the common ratio, N is still the number of the term. Now, example 1, given sequence 6, 18, 54, and actually dot, and they give us the last one. How do we know it's the last one for sure? There's a full stop afterwards, right? It indicates it's not carry on further. They say firstly, determine the next 2 terms. So now we need to determine R, just like how in arithmetic we determine D, the difference, okay? And how do we determine R is this formula, okay? It's not like a given formula. It's just something that you need to understand the concept of. R is equal to T2 over T1. Basically, you take one term and you divide it by its previous term. So remember, difference in arithmetic was T2 minus T1, okay? Or T56 minus T55. Now, similarly, in geometric, it's just divide. So T2 divided by T1 and is also equal to T3 divided by T2, which is also equal to T101 divided by T100. It doesn't matter which term, as long as you're using 2 consecutive terms, bigger one over smaller one. Right, let's continue given the sequence 6. Okay, so now we need to, in order to determine the next 2 terms, we need to determine R. So R is equal to T2 over T1. I'm going to use the smallest values. So 18 over 6, which is basically 3. So in this case, the common ratio is 3. So they are multiplying by 3 each time. Okay, I trust that we all use calculators. So 54 times 3, next 2 terms, I'm going to get 162. I multiply 162 by 3 and I get 486. Determine the nth term. Remember, nth term is basically Tn. They're asking you to determine the general formula. How do we determine the general formula? We determine the general formula by first using the general equation. A times R to the n minus 1, I believe. Yep. A times R to the power of n minus 1. Remember, my unknown is going to be n. A. So A is the first term, which is 6. R is the common ratio, which is 3n minus 1. Done. Okay. Remember, you cannot multiply this 3 and this n. Sorry, that's 6 and this 3 and call it 18 to the power of n minus 1 because this exponent is attached to just the space. Okay, let's do C. Okay. How many terms are there in the sequence? So they're asking the total number of terms that are in the sequence. So someone tell me, are we solving for Tn or are we solving for n here? Tn or n? Tn or n? Yeah, I see n's, I see two tn's. N. Okay, the correct answer is n. Okay, remember we are not solving for tn in this case because they're not asking what is the value of the pattern. They're not asking what what's the other way they phrased it? Or yeah, like what in the other question they said what number in the pattern is equal to 271? Which term is equal to 271? Okay, they're not saying that that term is equal to that. They're asking how many terms are in the pattern. Are they 5? Are they 6? This is we are working with n. Okay, number of terms in the pattern. So in this case, right, there's no like set formula for it. However, if you have the last term, okay, let's look at a simple pattern. Doesn't even have to make sense. 5, 7, 9. Say I have a full stop there. This is T1, this is T2, this is T3, this is T4, this is T5. Now, I have 5 terms in the pattern, and as you can see, T5, actually that number tells me how many terms I have in the pattern, because T5 is the 5th term. So whatever is the n of this number, okay, is going to tell us exactly how many patterns, how many numbers, or how many terms there are in this pattern. So basically, I have the value of the pattern, Tn. I need to solve for n. I need to know which term. Is it the 500th term? Is it the 7th term? Is it the 14th term? I have the value of it. So again, I equate my equation to that. So remember, I solved for it here. I have 118098, 118098 is equal to 6 times 3 to the n minus 1, and I'm solving for n. So I'm going to take 6 over as division, or simply divide both sides by 6, use my calculator, and I get 19683 is equal to 3 to the power of n minus 1. Okay, exponents. Now, when we have an unknown exponent, and when we have an unknown exponent, we want to get the same base. We'll cover this in detail when we do algebra, whenever we do a revision of algebra. But basically, there's also this method on your calculator for those who are here for the last year's workshop, where you put this in your calculator, 19683, you press equals to, and you press shift and fact. Okay, I'll write it down afterwards. Okay, fact, it's basically where the letter B is in red, or those like 1 dot and 3 commas. And it basically, it gives you the number in exponential form. So in this case, we know that 19683 can be written as 3 to the 9. My bases are the same. Once my bases are the same, I can drop my bases, and I get 9 is equal to n minus 1. I take that over, n is equal to 10. So this value is actually the 10th term. Since it's the last value, that tells me that how many terms are there in the pattern in total? There are 10 terms in the pattern. Okay, hope that makes sense. You know, there are so many questions to do, so many things. I do not want to skip out on anything. Okay, let's do this example. It's still geometric, okay, but obviously the first questions that we do are the basic questions. Now we're going to move on to slightly more complicated ones. Okay, it would be nice if I have the document, but it's fine. We can just freestyle. Okay, so this is T1, this is T2. Do they say that? Okay, yeah. So remember in the previous one, we had that whole dilemma about the first, second, and third term, and they didn't specify. Here they're specifying. They say that these are the first 3 terms. This is T1, this is T2, this is T3. They are the first 3 terms of a geometric sequence. Okay, so they specify. Okay, for those who had that question of when do we use geometric? How do we know it's arithmetic? A lot of the times they specify. Sometimes it comes down to you identifying that this pattern here has a common ratio. Sometimes you identify it as a common difference. Sometimes you'll have to identify it has first difference and second difference. In that case, it's quadratic. Okay. So we have these first 3 terms with unknowns. Okay. They say determine the value of g if g is an integer, firstly, and hence show that the first 3 terms are actually 18, 6, and 2. I don't know if you remember from last week, but I said whenever we have these unknowns, we are going to first opt to use the difference method. Okay, so in this case, we said it was T2 minus T1 is equal to T3 minus T2. However, in this case, we don't have a difference, we have a common ratio. So we're going to utilize that. Remember that the common ratio is equal to T2 over T1, and it's also equal to T3 over T2, and that's exactly what we are going to use here. So let's do that. Remember, our T1 is 4G minus 2. Our T2 is, no, I did that wrong. T1 is actually G plus 1. T2 is actually G plus 1. T1 is 4G minus 2. And T3 is G minus 3. T2 is G plus 1. How do I solve for this? I have to cross multiply 4G minus 2 times G minus 3 and G plus 1 squared, or G plus 1, G plus 1. Now I have to FOIL everything out. I'm going to get 4G squared minus 12G minus 2G plus 6 is equal to G squared plus 2G plus 1. Let's take everything over to one side and solve. I get 3G squared. That's minus 14G minus 16G plus 6 minus 1 plus 5. If there's anything wrong with regards to the calculation, please let me know. Can we factorize this? I believe we can. I need to get, so the second sign is a plus. I don't think we've done trinomial factorization with you guys as yet. And I know that there's some people who still don't know how to do trinomial factorization. 3G and G minus 5 minus 1. I think that's correct. Minus 15, it should be fine. So G is equal to 1 over 3, or G is equal to 5. Remember, they said that integers, it has to be G is an integer. Integers are whole numbers as well. So we cannot choose this. We have to choose 5. Okay, so therefore G is 5. So we know the value of G, which is the unknown in the pattern, which is 5. So we have to show that the first three terms are 18, 6, and 2. So 4 into 5, I can substitute G because I just solved for it. 4 into 5 minus 2, that is, okay, it has to be 18. So 20 minus 2 is 18. G plus 1, so 5 plus 1, 6. G minus 3, 5 minus 3, 2. Okay, so the first three terms I've just shown are 18, 6, and 2. Write down the nth term of the sequence. This is geometric. So we have Tn is equal to 8 times r to the n minus 1. So I have A. I just solved for it. It's 18. So even if you didn't solve A, you could still solve B because they've actually given you the value of the first three terms. So you can solve B. Okay. You just had to prove it in the first question. But if you couldn't solve the first question, you can still solve the second question. So A is 18. R is, did we determine R? Okay, we haven't determined R yet. How do we get R? R is basically T2 over T1. So T2 is 6. T1 is 18. This simplifies to 1 over 3. This time it's a fraction. So 18 times 1 over 3 to the power of n minus 1. Okay, and that is our solving for Tn. Let's move on to this next question. I think this next question is a bit complicated. Okay, I think I'm going to skip out that question and move on to series. A series, just for the sake of time, we literally just have 5 minutes left. A series is the sum of a number of terms in a sequence and is represented by Sn. Okay. Okay, so basically we deal with sequences and series. I'm sure you guys just learned this as sum, but basically it's arithmetic series, right? That's the correct term for it. But yeah, it's represented by Sn. So instead of Tn, it's Sn. And it is basically the sum of all the patterns. So you are adding up all the patterns. So for example, in my simple pattern, where's my simple pattern? Where is that pattern? Maybe I erased it. For example, let's look at this. There's 4 numbers. S4 would basically be adding the first 4 terms up. So 1 plus 3 plus 9 plus 27, that would give us S4, the sum of the first 4 terms. Okay, so we're going to work with arithmetic series. So the general term for the arithmetic series or sequence is that, right, it has its formula, Tn is equal to a plus n minus 1 times d. Now the sum formula for arithmetic series is Sn is equal to n over 2, open brackets 2a plus n minus 1 times the difference. Okay, there is another version of this formula, which is this guy. If you have the last term, you can utilize this formula. So Sn is equal to n over 2, remember n is the number of terms, into first term plus last term. Okay, the proof, right? So the proof is examinable. Let us discuss the proof, okay? So one thing about the proof is you don't actually have to understand it. It's good to understand it. It's easier to memorize. You could memorize this entire thing, and if it's asked in the exam, you could write it in the exam and you get full marks, right? So let's look at what they do. Basically, they write out a formula for Sn. So Sn is equal to, right? Remember, we're back to arithmetic, right? So A is first term. Okay, so this is T1. Then A plus D, remember A plus D. So now you're adding the first difference. So now you are forming T2. Then you take A plus D and you add another difference. It becomes A plus 2D. So you are forming T3. And so on and so forth, right? T4, T5, T6, whatever, however many patterns there are. Okay, so I hope that makes sense. You're just adding the difference. That's how you get T2. And you add 2 of the differences. That's how you get T3. Now they put a dot, 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 indicating, okay, all the patterns that fall between that. Okay, let's look at from the end. What did they do here? They basically made use of the formula. Okay, how do we calculate the last term? Now, remember n, right? We are dealing with n, Sn. Now, when we deal with Sn or Tn, n could be anything. So we have to have a general term that tells us, okay, whatever n is, if you use this formula, you are going to get your answer. So you can substitute 5, 6, 27, you are going to get the correct value of that term. So that's why in this case, we are dealing with Sn. Now remember, the number of terms, if I had to ask you, I'm just dealing with Sn, how many terms are in this pattern? You would say n number of terms. Because whatever n is, that's the total number of terms that you are actually adding up in this case. But basically, that's the total amount of terms in this pattern that we're summing up. So that's why in this case, right, remember, this is the general formula for arithmetic. It's the formula that tells us, what does it tell us? It tells us that no matter what value for n you substitute here, you're going to get the correct answer. In our case specifically, n is the total number of terms that there are in this pattern. So therefore, the last term, you could just use the formula. And n, if there were 30 terms in this pattern, then n would be 30. And it would be S30. We are summing up the first 30 terms. That's why this n would be 30. Okay, but we just write it as n because remember, it could be 30, it could be 40. We don't know actually how many terms we are substituting here. So that's why we are writing for the last term, the actual arithmetic formula. Then going one back. Okay, now n minus 2. So if this is 30, this is 29. Okay, it's n minus 1, by the way. So if there were 30 terms, this would actually accumulate to 29 because you are saying n minus 1. Okay, but let's just say that is 30. And n minus 2 would be, okay, let's just not say. So let's just say n is 30. If n was 30, this would add up to 29. Then here, n would be 29, of course. And this adds up to 27. It doesn't really matter. Should add up to 28. What are we doing wrong? Oh no, it's n. N doesn't change, sorry. N is again the total number of terms, 30. Okay, we're assuming that n is the total number of terms. So this is n minus 2, 28. 29, 28, 27, and so on. Okay, so I hope that makes sense. Again, doesn't need to completely make sense. As long as you can memorize it, it would work. Okay, but basically I'm explaining it to you so that you understand it and that it's easier to learn. Okay, geez. So yes, n minus 1, n minus 2, n minus 3, and so on. So you can just write it dot, dot, dot. You don't need to write all. Then what they are doing is they are adding another Sn. So the reason as to why they're doing it is not important, but knowing it, how to do it, is really important, right? So they're adding another Sn. However, okay, in this example, they are working backwards. So they are writing the last term first, then the second last term, then the third last term, and then from the back they're writing the first term, second term, third term. Okay, you'll see as to why they do this, but this is basically what you need to do. And then when you add them, so if you add them in a row, if I'm going to add a into that, I'm going to get this 2a plus n minus 1 times d. If I'm going to add this to that, I'm going to get 2a plus n minus 1 times d. Okay, actually, because when you multiply this out, you get minus 2d. And if you're plusing d, you're going to get the same thing. Okay, then when you add these together, you're going to get 2a plus n minus 1 times d, and so on and so forth. 2a plus n minus 1 times d, 2a plus n minus 1 times d, and so on until how many 2a plus n minus 1 times d's are we going to have? We are going to have an n number of 2a plus. Okay, so remember when we add Sn and Sn, we get 2Sn. So that's how we get that on the left-hand side. On the right-hand side, we are adding all of these 2a plus n minus 1 times d, 2a plus n minus 1 times d. How many times? However many patterns there are in the term, so n amount of times. In amount of times. And therefore, we need to leave Sn alone, take 2 over, we divide everything by 2 there. And that's how we form this proof. Is the arithmetic series in the grade 12 curriculum? Because I haven't been taught this before. Yes, definitely. You can be tested on some of arithmetic. Or are you talking about the proof itself? Okay, so we have arithmetic series, the proof. Okay, unfortunately, time is up. So next week, we are going to continue with, questions on this. And then we still have geometric series and its proof and questions. We have sum to infinity. We have sigma notation, practice, and then some difficult examples. Okay, just before you guys leave, I need to ask you guys a question. The question has disappeared. Has it disappeared? Let's just see. Okay, no. Okay, so I have a question for you guys. I just want your guys' opinion. When we start with functions and circle geometry. Circle geometry. You have started circle geometry. Why have you started circle geometry? That is term 2. Functions, we will start as soon as we finish. I assume most of you are busy with functions currently. Functions, we will start as soon as we finish this topic, which is sequences and series, and then we move on to trigonometry. Okay, so we are thinking of having 2 additional math classes per week. Okay. However, there might be a small fee involved. Okay. It's going to be a monthly fee. Okay. Within the range of like 150 to 200 Rand per month. Okay. We're not 100% certain yet, but would you guys be interested in something like that? Because obviously we can see that the time allocated for this, for math, like 1 hour a week is tight, right? To cover all these topics. Like there's nothing that I want to leave out at the end of the day, right? There could be students that benefit a lot from the basics, okay, as well as benefit from the difficult questions, okay? So I'm trying to encompass like all of that. Okay, so tell me, let me just tell me, would any of you be interested in that? I would just like you guys' feedback. On YouTube, you guys could also let me know. Can these notes be sent to us? Yes, these notes are in the group on the Google Drive. There's a link to the Google Drive in the description of the group, and you can access your notes there. Okay, I see many yeses. Okay, that's really good. So we are considering it, and we'll obviously communicate with you guys going further. If you would be interested in the classes, how would you need to pay? Okay, we'll communicate with you guys. Okay, as we confirm things and as we can get everything sorted. Okay, cool. So for now, we end on this, all right? Next week, we will continue with this. I know next week we are actually going into the Today's date 13. So next week we are going into the 1, 2, 3, 4, 5, 6, 7th week of school. So you guys should be actually finishing functions by next week. So hopefully we can finish this up and then start functions the next week. Okay. So yeah. Okay, cool. Those notes, remember, they'll be sent to you guys. All right. So then, okay. Yeah, with regards to those classes, again, we will contact you. Okay. Thank you guys so much for your feedback. I will then see you guys next week. Okay. All the best for your guys' school this week. And again, I'll see you guys next week. Okay, cool.